Well, I can't really play that yet. Oops. Better do some electronics instead. Here we go. Okay folks, let's have a look at the coding in Python that goes with our strobe and Rev Counter using the little ESP32 microcontroller. So we're going to be talking using Micropython, and we're going to be using different constructs to the usual ones. We're not using loops and iteration and conditional things like while, if, and that sort of thing. We're going to use interrupts and we're going to use timers. And that's all we're going to use really. We don't really need anything complicated. So we're going to use the little box we've made. Got the strobe thing on the back and it's got the LCD on the front, and we're going to plug it in really simply, just using the little USB cable. Plug it in and we're going to use Thonny, Thonny, to use as an IDE, as a programming program. And we're going to connect up and see how we go. Here we go. Okay guys, let's have a look at the ESP32 Rev Counter and strobe timing light. On the screen you can see I've got the Thonny app with the program there, and I've got a camera set so you can see what's happening to the device. Now at the moment, to be honest, if I do stop and try and reconnect, it can't reconnect because we're not connected up and the thing is not powered. So what I'll do first of all is notice that I've got the link out so that we're not powering the ESP32 from our 12 volts. This is our 12 volts, by the way. Yay! 12 volts is up, but the ESP32 is not running. So everything else is powered. So let's power up Mr. ESP32 with the USB power, and this is purely for testing. Now you'll see now that it's actually the LCD is working and the programs run automatically. This is because we're running main.py. Main.py is the program that starts automatically on an ESP32 or any microcontroller probably. Let's get rid of untitled there. There we go, main.py. I'll just stop the program. I think I can stop it like that for the once, and that's okay. There you go. And down the bottom I've got a prompt, and now I know I'm talking to the ESP32. Notice that we're on version 1.16. I upgraded this just recently, which you can do by flashing it from a PC, desktop PC, which you can find out on the web yourself. Oh, yeah, no problem. Right, let's start the program running and see what happens. So I'm going to start the program running. There we go. This is my program. And all it's doing is it's running an interval periodically and counting the number of pulses that happen during that interval. Now it's using interrupts, which is interesting and new for Python. So we're doing a timer interval, and that creates a software interrupt at the end of its interval. And we're doing a hardware interrupt from the GPIO that says a pulse has happened. So not much has happened at the moment. RPM 0, pulses are 0. I'm going to use my trusty little, where is it? 10K resistor here. Here it is. Yay, it's a little one. And we're going to just pretend that we're a pulse from the ignition on my car. We'll do a few pulses. There we go. There you go. There we go. So we've got some pulses, and the RPM count is 80, which is just a simple multiply by 10 by the looks of it. And then we go back to 0 again. So it's running okay, that's no big deal. Brilliant. Right, let's try and stop the program and see what happens. Normally you'd expect it to just stop and you'd be okay. But because we've set a timer to run on the ESP32, there is no way to stop that timer. And it's still running, the little blue light's flashing. And it says press stop to stop it, and it's still going. Honestly, I don't know. And the little blue light is still flashing. Now the only way to stop it is to pull out the USB, which I've just done now, and then the ESP32 is unpowered, and then pull it back in again. And then you can stop the main program running now, and I think then we're okay. It's not running the little blue flashy light, and it's not running the main program. Tricky that. Okay, so let's have a look at this program in a little bit more depth and see exactly what it's doing. Interesting program. First of all, before we look through main.py, I'm going to do file open, and on Thorny you can choose Micropython device or this computer. I'm going to choose Micropython and have a look at what's on my ESP32. We have limited file capabilities on this. You can't delete files, but you can set them to 0 files by overwriting it. So what have we got? Boot.py, don't touch that. That's okay, that runs for the machine. Main.py is what we've got at the moment. That program runs automatically. So I've copied the contents of my RPM meter into main.py. It's updated a little bit, it's slightly different size there. Now you need 2 more files for this to run. And you need to open them from the PC and then save them to the Thorny microcontroller device. You need LCD underscore API, and that's the application program interface for the LCD. And you need ESP32 GPIO. That means we're connecting it by wires. It's on a 4-bit parallel connection. So you need those to run there. Let's not open that really. Let's have a look. I've got a lot of comments at the top here. Now I've got from machine import everything. From that ESP32 GPIO, we're importing the GPIO bits that we need. From UTime, uptime, we're looking at sleep milliseconds instead of time and time.sleep, just for a change. Nice. Right. LCD, first of all, we're setting the LCD parameters and saying these are the pins that we're using for the LCD. And you see it's got 4 data pins, D4 to D7. And it's not the 8-pin version, it's the 4-pin version. You set the number of lines, the number of columns, no big deal. I'm going to hide the cursor because I don't want a flashing cursor on this thing for today. And I'm defining Spark as an input pin, GPIO, and I'm going to pull up because of my circuit, the way it works. And it's an input, and it's the pulse from the spark detector, so the spark on the engine gives 1 pulse. Now, I'm not going to run a while true loop or do anything normal in Python for this. I'm going to let this run as an interrupt. If I look further down here, but just jump ahead a little bit here, I've got spark.irq, and that means set the spark input as an interrupt. So when that pulse goes, in this case, falling, goes down to 0, it will generate a hardware interrupt. And it will interrupt my program, and it will then run an interrupt handler program, which I've defined as pulse add. And pulse add, first of all, pulls in pulse count as a variable, makes it global, and messes around with pulse count. You can't do very much on these handler routines, it's got to be fairly simple. Adds 1 to the pulse count, and then it prints it on screen. I don't need to print it on screen, really, it's just for my testing purposes. Let's go back to where we were before. We've got LCD write, which is just a simple command to write some stuff on screen, and we're inputting the parameters RPM and the pulse count. I don't need pulse count really for the purpose of this device, but hey, makes me happy. Yeah, grand. Right, LCD clear the screen, move it to 0, that moves the cursor, put string. Notice that this is an entire string here, and you've got to use the plus sign in between. You can't use a comma like you do in print. But you can't print one thing and the other thing, you've got to print one big string. So you concatenate them by doing plus. And you can't just print RPM or a variable or an integer or anything like that. You've got to print a string. So this is a string of RPM using the string function. Okay, move the cursor, put another string there, and sleep 2 seconds. Ooh, do I really want to do that? Yeah, that's actually, is that going to... okay, that's all right. Right. End interval counter. This is at the end of every interval. And notice down here we've set up, where's it gone? We've set an interval for the interval counter. And at the end of every interval, we'll access the blue LED pulse count RPM and interval, and we'll put the blue LED on briefly for a very brief amount, 50 milliseconds, and then off again. That messes up my timing a bit, but keeps me happy because I like the flashing lights. Yeah, grand. Blue LED off again. RPM equals, there's the calculation that tells you what the RPM is from that, uses the interval, uses the pulse count, and it's 60 seconds in a minute, and then it's got 1,000 milliseconds, so there you go. Also, you need this line here. You could do it on one line if you want, but I've not, just because I'm simple, and I just like simple things. This is because the spark occurs every 2 engine revolutions. It's a 4-stroke internal combustion engine. If you're using a different cycle, it would be a different number. The Otto engine or something different, I don't know. Right, RPM displays on screen. This is an interesting little bit here. It's got a format, and it tells it there's no numbers after the decimal point, and indeed no decimal point. I just want an integer for this, and the integer function doesn't seem to work for me, so I've used the format. Print RPM on screen. Yeah, that's okay, no big deal. That's just for testing purposes. It will appear on this IDE, but I want it on the LCD really. So LCD write RPM and pulse count. And then pulse count is 0. At the end of the interval, we set the pulse count back to 0 again and start counting again. Okay, so we've done that one. Main program starts here. Clear the LCD. Put string, there you go, Harold Spuds meter, sleep a little bit, and put string there. Blue LED off, set everything to start with. This is the line here that sets the software interrupt, the software timer. You've got 4 timers available in Micropython. We're using the first one. We'll call it timer 1, although the actual because it counts in Python counting, it starts at 0. Then we'll say timer1.init. We'll say frequency is 0.5, so it's going to do an interval of 2 seconds, and it will update 2 seconds. Mode is timer periodic. You can do aperiodic or one shot if you want, but today we're doing periodic because we continue forever. And callback. This is the call handler that happens, that's called at the end of the interval. End interval. And there's our end interval timer there that does all the pulse stuff and it prints out on screen. And that's it. That's the program. So we start the program running. Can we start the program running? Yeah, I suppose we can. Off it goes. And I can count pulses, and I can count RPMs, and all is well. Now, one thing to note here, I'm just going to pull the power on this on the USB. I'm going to pull the power on the USB here as well. So now I've taken out the USB from the Micropython device. It's still got something on the LCD screen, it's still powered. It's remembering what it's got. Let's just take our power off. So everything's unpowered now. I'm going to put the link back in that powers the ESP32 from, I can do it, the 12-volt power supply. Now, we don't do this while we are looking at phonics, so phonics is no use to us now whatsoever. And I'm just going to power up on 12 volts. So everything's powered now. It'll take a little while for the LCD screen to come on. And this is how it will work when it's really running. There we go. Harold Spuds, RPM, meter, and off it goes. And now it's working. And it's powered on its own by 12 volts. There's a little 7805, just point to this thing here, 7805 voltage reg here with some little capacitors to smooth it out. And if we then put some pulses in now, it will still work. All works very fine. And there's some pulses. There we go. And now I've got 2 pulses in there, and the RPM is 20. Ooh, there's 4 more there, and that's it. There you go. Back to where we were. One thing to note, very, very important, because I thought this thing was broken when I built it, is this little trim pot here. And that adjusts the contrast on the LCD. And if you don't adjust that, then you just get a blank screen and you think, oh, broken. But it's not. It just needs adjusting. And that's it. So all we need to do now is put it into a box and make it work and see if it works on that engine. Splendid. Good.